Good afternoon students. Today class I am going to discuss about circular motion. So in the previous classes we have gone through the position of a particle in a plane. So here why we are going to describe about the circular motion, because any particle which revolving in circular path has two directions, means the particle also moving in two dimensions, right? Yes, the concept we are utilizing in this way. So let us take that what is a circle. For example, let us take a circular motion. Here when a particle moves along a circular path, the line joining the particle to the axis of rotation is called what? Radius. Means for example, there is a particle moving along the circular path with having some velocity. So what we are seeing, that the line joining the particle to the axis of rotation. So if you draw a line to the axis of rotation, anything here, so that is called what? Radius. That is called what, ma? Radius vector. Now the angle subtended by the radius vector in a given time is called angular displacement. For example, the particle is at A initially and reaches up at point B. So the angle subtended here, the angle described by the radius vector in a given time is called what? Angular displacement. This theta is called what, ma? Angular displacement. So since it is rotational motion, we consider displacement in angular terms. So what we can define here? The angle described by radius vector in a given time is called angular displacement theta. So represented by letter what, ma? Theta. It is measured in, as we know in the first chapter we learned that plane angle is measured in what? Radians. So the SI unit is radian, and since it is supplementary quantity, it does not have dimensions. For example, the particle is moving and making angular displacement theta in a time interval t. So we can say that the rate of angular displacement, the rate of displacement is called velocity, the rate of angular displacement is called angular velocity. Okay, the rate of angular displacement is called angular velocity. Omega is equals to theta by t radian per second. So if a particle is moving in circular path, we can say that the line joining the axis of rotation is called radius vector, and the angle subtended by this radius vector in a time t is called angular displacement, and the rate of angular displacement is called angular velocity. Now coming to the point, what that? Uniform circular motion. What is uniform motion, circular motion? The motion of a particle along the circumference of a circle with uniform angular velocity is called uniform circular motion. Means the particle which is moving along the circumference of the circle should be having uniform angular velocity, that is called what, ma? Uniform circular motion. So what we define? The motion of a particle along the circumference of a circle with uniform angular velocity is called uniform circular motion. In uniform circular motion, we should note some points, that is what? I want to find the velocity of the particle. If you draw a tangent at any point, for example at that instant this is the velocity, see at that instant this is the velocity. So here at each instant in circular motion, if you draw the tangent drawn at that point gives velocity direction. A body moving in, so we already clearly said that In uniform circular motion, the particle moves with uniform angular velocity, which is similar to uniform velocity. What that? This particle covers equal angular displacements in equal intervals of time. For example, here the theta is 30 degrees, it takes time is 2 seconds, next 30 degrees also 2 seconds, next 30 degrees also 2 seconds. So, a particle moving in uniform circular motion covers equal angular displacements in equal intervals of time, and the velocity direction of the particle at any direction is what? Drawing a tangent. Here one point we should remember, in uniform circular motion the speed remains constant, means the magnitude of speed remains constant, whereas velocity will changes. So, you are saying that speed remains constant, but velocity is changing. How? See here, velocity is a vector quantity, velocity is a vector quantity which depends upon both magnitude and direction. Here the magnitude of speed remains constant, but have you observed at each and every point what is changing? The direction of the particle is changing or not? So, see here the direction, this one, here the direction. So, the direction changes. If the direction changes, velocity also changes, means velocity changing means it is getting acceleration. What is that acceleration? We will discuss. Okay. So, very important point we should remember that what? In uniform circular motion, speed remains constant, velocity changes. Why? Because direction changes. At each and every point the velocity direction changes, so velocity is changes. This is the important point we should remember. Okay. Now, we are saying that velocity and angular velocity. Angular velocity is what? Rate of change of angular displacement. Let us find the relation between V and omega. That is, now I am going to discuss or derive the relation between linear velocity and angular velocity. See, this is a small relation between V andreno linear velocity, omega angular velocity. So, V is called what ma? Linear velocity, and omega is called angular velocity. Let us find the relation between these two. So, let us take as usual circular path. This is center of the circle. From this, initially the particle is at point A, as we know this is radius, and after some time t it reaches a point B. Is it right? Now, the displacement of the particle is what? As we know, this is also r. What is this? Yes. We already said that the angle subtended by the radius vector in a small time t is called angular displacement. The particle is moving with angular velocity omega. Okay. So, consider a particle moving along circular path of radius r with uniform angular velocity omega and linear speed v. Let us assume that the particle moved from A to B and the displacement of the particle is s, and making an angular displacement theta. As you know that if you consider this is a triangle, from triangle OAB or AOB, tan theta is equals to what ma? Opposite side by adjacent side. What is the opposite side? S by r. As we know, we consider the displacement is very small. If theta is small, what can I write? Tan theta is equals to theta. Therefore, theta is equals to what? S by r. That implies S is equals to r theta. So, we got displacement, right. Okay. Now, as we know, rate of change of displacement, what I am doing here is differentiating on both sides, or rate of change of displacement we know what is that, velocity, right. V is equals to S by T. What is S? R theta, right, R theta by T. Now only we learnt the rate of angular displacement is called omega. So, I am writing this as V is equals to R omega, where omega already we said angular velocity, that is equals to rate of change of displacement. So, this is the relation between linear velocity and angular velocity. And now you have to know that when a particle describes circular motion, the time taken by particle to complete one cycle is called period of revolution. Is it right? So, here if the particle takes some time to complete one rotation, that is called what ma? Time period. What is time period? The time taken by a particle to complete one revolution. Is called time period. Means how much time taken by the particle to complete one revolution is called what ma? Time period, capital T. For example, in 1 second it has done 10 revolutions. It is possible, right? Yes, for electron it will do lakhs of rotations or revolutions. So, that number of revolutions done in 1 second is called frequency. Okay. So, here what is the logic? The time taken by a particle to complete one revolution is called what? Time period. Now, the number of revolutions made by the particle, the number of revolutions made by the particle in 1 second is called frequency. It's called what? Frequency. There is a relation between these two, that is F is equals to 1 by T. Frequency is measured in hertz or representable letter Hz. Okay. There is one more unit, that is called CPS, and then cycles per second or rotations per second. Time period, as you know, it is measured in seconds. As you know, if you want to complete one rotation, what is angular displacement? 2 pi or not? To complete one cycle, the total angle covered is what ma? 360 degrees. So, that is nothing but 2 pi, as you know that pi is equals to 180. So, what I can write here? There is one small relation that during one complete rotation, or one complete revolution, angular displacement is two pi. Is it right? How much time taken? In time interval of capital T. So, we can write angular velocity as what? Omega is equals to 2 pi by T. Theta is equals to 2 pi, time period is equals to T, that is equals to what? Velocity. That is equals to 2 pi F. Why? Because F is equals to 1 by T. So, these are the basics that to understand a concept called centripetal acceleration. So, what we learnt here? A body moving in circular path. The line joining the axis of rotation is called radius. the angle subtended by the radius vector in a time t is called angular velocity. Here a particle moving in uniform circular motion, speed is constant, but velocity changes. Why velocity changes? Because if you want to find what is the direction of velocity, you should draw a tangent at that point. The tangent drawn at that instant of time gives direction. Here in this uniform circular motion, at each and every point the velocity direction changes. So, velocity changes in this case, means it is getting acceleration. Uniform circular motion means the particle moving in circular path covers equal angular displacements in equal intervals of time. That is, omega is constant, whereas v is changes. And we come to know one new concept called angular velocity. That relation between v and r has been derived, that is v is equals to r omega. Here a particle is continuously moving in circular path, takes some time to complete one revolution, that is called time period, and the number of revolutions made in 1 second is called frequency. The relation between frequency and time period is f is equals to 1 by t, and as we very know that to complete one rotation, total angular displacement 2 pi and taken time is t. What is angular velocity? Angular displacement. What is angular displacement? 2 pi. Time taken is t. So, 2 pi by t, that is equals to what? 2 pi into f, because f is equals to 1 by t. So, along with this I am sending a small video based on vectors. So, types of vectors, and this video you have to see today. Thank you, students.